On our 2.2, we will try to graph piecewise function. Let's look at problem number 1. On problem number 1, I have f of x equal x when x is less or equal than 0, or 1/2 of x plus 2 when x is greater than 0. The first thing you want to do is plug in the value that the interval is changing. So here is x equals 0. It's kind of the boundary. So if you plug in 0 for x, obviously for this function, you will also get 0 for y. And if you plug in 0 in this second function, you will end up with the point 0, 2. Those 2 points are very important. For the first function, the point 0, 0 is a solid point. So I'll put a solid point here. For the second function, the point 0, 2 is an open point, or an open circle, because I don't have the or equal. So at 0, 2, I will have an open circle. That's the first thing to do. The next thing to do is to graph the line y equals x, the whole line. So if I want to graph the line y equals x, it will look like this. This is how the graph y equals x will look like. Of course, it will go on both sides. Now, remember, this function is only defined for all the x's that are smaller than 0. So apparently, I cannot go past my solid point. So I will have to erase it all the way up to the solid point, which is here. And of course, it's not an arrow, it's a point here, the solid point. Now, for the second function, I need to graph the line 1/2 x plus 2. To graph the line 1/2 x plus 2, it seems like I'm starting at 2. I'm going to rise 1 and run 2. So it will give me this point. So let me go ahead and graph that line, and I will graph it in the restricted range, meaning from 2 up to infinity, because it's from x greater or equal than 0, so I cannot pass the 0 line. And this is your piecewise function. Of course, arrow here and here. Let's look at the second problem. For the second problem, what I will do is, again, check it for my -1. So I will plug in -1 in here. And if I plug in -1 for x, I will end up at 1 for y. And if you plug in -1 for x on the second one, you will end up again with 1. So at the point -1, 1, meaning -1, 1, I will have, it will be a solid point. So I will go ahead and graph the first one. For x equal, I will graph the line x plus 2. The line x plus 2, it means I'm starting at, since this is a solid line, I'm starting at 2, meaning here, and I will rise 1, run 1 here. So if I want to graph this, it will be it's a line, since it's linear. It will be this line. But keep in mind, the line that I just graphed must only be defined between, at every value less than -1. So I shouldn't normally cross the solid point. So I should normally start there. For the second one, of course, these are not important. For the second one, I will start by graphing a quadratic function. The quadratic looks like this. It's a u, and it goes also all the way to here, but I want only the value that passed -1. So I have an arrow here and here. It's not hard to graph, just follow one function at a time. All right, greatest integer function, y is equal to the greatest integer of x. The greatest integer is never, let's say for instance, first of all, let me say you always round down, never round up, round down. For example, if I give you 1.5, you will round down to 1, and so on. But before I get to it, I think I forgot to give you the domain and the range of these. Let's start with the domain on top. The domain will be all real numbers, because although we have a break here, this is solid, this is open. So it's from -infinity to infinity. And the range, on the other hand, starts from -infinity. If I travel from bottom to top, I will stop first at 0, and I have bracket at 0. Union, I pick back up at 2 with a parenthesis till infinity. The domain on this is negative infinity till infinity because it's defined everywhere, and the range as well is negative infinity till infinity. This function is continuous compared to this that will not be continuous. All right, let's go ahead and do the greatest integer function. If I want to round everything up, it means that from 1, let's add from 0. From 0 up to 0.1, I will round it down to 0. But at 1, I will not round 1 to 0, because at 1, it will be at 1, up there. If I keep going with this pattern, 1, 1.1, 1.2, and so on, up to almost 2, but not 2, it will be rounded to 1, so I make it solid. And this we keep going, and so on, and so on. Even on the negative side. And this is your greatest integer function. Let's talk about the domain of this. Obviously, it's defined everywhere. It's from negative infinity to infinity. But the range is important. The range will only be integers. All right, let's evaluate this one. The greatest integer of 2.3 is 2. This one will be 5. Although it's 5.89, we're not rounding up, we're rounding down. Between negative 5, for negative 5.1, it will actually be negative 6, because the slowest, if we round it to negative 5, then we round it up. Negative 6, we'll be rounding it down. Of course, for 4 would be 4. All right, the graph of f of x is given. Find the interval where f is increasing and decreasing. This is a very simple one. Let's start with increasing. It is increasing from negative infinity, meaning on this side is increasing. Increasing is when it's going up. It's also increasing from this point up to this point. That's increasing. So it's from negative infinity till A, union from B till C. Let's talk about decreasing. This function is decreasing from A all the way till B, and it also decreasing from D all the way down till infinity. So it will be from A to B. This time I can put parentheses also. Union is that back at D all the way to infinity. From C to D is constant, so I don't include it for increasing or decreasing. Use your calculator to find the interval where f of x equals x to the power of 2/3 is increasing and decreasing. Again, this is using your calculator, but your calculator will show you a graph looking like this. Obviously, it is increasing from 0 till infinity and decreasing from negative infinity to 0. You already know that the slope is the rate of change, and it's the change of y over change of x. Most people will say delta y over delta x. The average rate of change. To find the average rate of change, let's say for instance I have a function looking like this. The average rate of change from this point to this point is actually as if I have a line here. Now, the coordinate of this point will be x1 comma the function f of x1, meaning the value of y of when x1 is x. And for the second point, meaning this point, the coordinates of this will be, I'll say x2 and f of x2, meaning the y value of x2. So to find the rate of change, I would say change of y, meaning f of x2 minus f of x1 over, again, this is your y2 minus y1 over x2 minus x1. And this, of course, is the function f of x. All right, Let's do one example. Let's say I have the function f of x equals x minus 3 squared. Find the average rate of change on the interval 1 to 4. So the first thing I will do is find f of 1 and f of 4. F of 1 is equal to 1 minus 3, the whole thing squared, which is equal to 4. And f of 4 is equal to 4 minus 3, everything squared, which is 1. So to find this rate of change, I will do y2 minus y1, meaning 4 minus 1 over x2, meaning 1. If I do 4 minus 1, I do 1 minus 4, which is equal to 3 over negative 3, which is equal to negative 1. And this is your rate of change in this interval. Last problem. A falling object distance from the ground is given by d of function of d in terms of t is equal to 16t squared. Find the average speed between 1 and 5. Since they say between 1 and 5, I know this is my x1 and this is my x2, both of them in seconds. To find that average, first thing I need to do is find d1. d1 is equal to 16 times 1 squared, which is equal to 16. And I also need to know d5. And d5 is equal to 16 times 5 squared, which is equal to 400. To find this average rate of change, I will say it is 400 minus 16 over 5 minus 1. And this one will give you 96, and the unit here is, let's say feet, 96 feet. The next question says find the average speed between the interval a and a plus h. That means I will do d of a plus h minus d of a over a plus h minus a. This should ring a bell in your head by now. Anyways, a minus a, obviously the a's will cancel, and I will keep writing it. D of a plus h will be 16 times a plus h, the whole thing squared, minus 16 times a squared over h. Now I can explain this one by saying it is 16a squared plus 32ah plus h squared minus 16a squared. Once again, this is like your after party 3, I believe. This is over h. Now I can simplify even more. The 16a squared and negative 16a squared will cancel, and I can factor an h out of these two. So if I factor an h out of those two, I will have h times 32a plus h over h. The h will cancel, and I'm left with 32a plus 16h. I forgot to put a 16 here. All right,